Okay, at the beginning of class, you should have copied this down into your notebook on the next available page. This is going to become your study guide for our next quiz. Yay, quizzes! You're going to be asked to put all of these scientists in the proper order and know what their contribution was, okay? It's not that hard because I'm going to show you ways to remember, okay? And I'm going to give you days to study. I'm not going to remember. I don't do pop quizzes because that's not nice. Okay, so, oh, I forgot to put my drawing up there. This box for the live image for the Elmo and what's pictured in it is what you're going to put in the model portion. Oh, look at that on the first try. Okay, so what you see in this box right here will go in here for each of the people, okay? So I'm actually giving you the information versus you researching it. Tell me how wonderful I am. You're welcome. Okay. All right, so it's really important to understand how the model of the atom that started, which is now like this, which is the one we talked about, and has turned into, from what it's turned into, from what it started with. So the first person we're going to talk about, this little arrow thing's in the way. Why can't it work? There we go. Okay, so in this part, you're going to put what the contribution that scientists had towards the current model, okay? And we're going to start with Democritus. So you should be drawing this in here, okay? Now, Democritus, he was a Greek philosopher in 440 BC, and he was pretty cool. He walked around in a toga, and he's like, cool, I'm cool. I've got my wooden sandals and my white toga and my green leafy head gear. I don't know what he was rocking. And one day he said, you know what? I think that matter is made up of little stuff. I think that atoms exist, basically, is what it was. And in 440 BC, was there any technology to prove his theory? No, so it's actually a theory. So in 440 BC, he's like, you know what? I think that I can take this rock and break it down in half, in half, in half, in half, in half, in half, finally until I get to a piece that I know I will no longer be able to break in half. So his contribution was, hey, atoms exist and they're indivisible. They cannot be divided in their smallest piece. So it was like he said, hey, I have this pizza I want to share with my friends. It has nothing but olives on it, which is why it's black. Okay? And then I'm going to cut it in half. Oh, I have another friend. I have to cut that in half. And so on and so on and so on and so on until he got to the smallest piece that can no longer be broken down. Again, his contribution was that he said atoms existed. And when it gets to the smallest piece, you cannot break it down anymore. Okay, now Dalton, he just went further with Democritus, but this happened in like the 1800s, and he proved through experiments that atoms existed. He proved through experiments that atoms existed. And he said that atoms were invisible, indestructible, solid spheres that looked just like that. So Dalton said that he proved that atoms exist through experiment. Then we move on to J.J. Thomson, who he is accredited for discovering the electron. So he's famous for discovering the electron. That's basically what he's known for. He also came up with the plum pudding model because they used to have this dessert back in the day that was like plum pudding with raisins in it. I know it totally sounds disgusting because ew. And I guess it's kind of like bread pudding, but I don't like bread pudding, so whatever. He said that this is like basically the whole atom. So this would mean that all the protons are together with the negatives, and so that he would look at his plum pudding and see the raisins and say, hey, those kind of look like electrons. And so that's basically what his plum pudding model looks like. So he was famous for discovering the electron and the plum pudding model. Okay. Okay, so the next guy on our list is Ernest Rutherford. And Rutherford, he was actually a former student of J.J. Thomson. They worked together. So it only makes sense that he would, make further discovery as far as the electron is concerned. But he was the first person to discover that there was a nucleus and that the electrons were not located on the nucleus, but around the nucleus. So he kind of debunked Thomson's theory and said, yes, there are electrons, you are correct, but they're not in the nucleus, they're around the nucleus. So that's what his contribution was. He also made a huge contribution in discovering that atoms were mostly empty space. So he discovered the nucleus and discovered that atoms are mostly empty space. Okay, so after Rutherford came James Chadwick, and James Chadwick doesn't actually have a model, so you can go ahead and put an X on this part of the chart. It's he's just famous for discovering the neutron. That's all you need to know about Chadwick. So no model, but he did discover the neutron. He's the I don't care guy. I don't care. I love you. I don't care. I hate you. I don't care. Whatever. Okay, and then the next guy is probably the most important to you guys, which is going to be the Bohr model. Okay, Niels Bohr, he agreed with Rutherford and said, yes, the electrons are located outside of the nucleus. However, they're located on specific energy levels. So Bohr was the one that said electrons are placed on energy levels, and that's the only place that they can be. Another wording for energy levels that you may want to put in parentheses would be orbits or paths, both acceptable words for energy levels. And they can only be, like, a certain number of electrons can only be on each path. And this is what the first model you guys are really going to work with and learn about, and actually the one that we work with the most in here. And he also believed that the electrons went around the nucleus like the planets orbit the sun. So he was responsible for energy levels, basically. Any questions about Bohr? Can I move on? What? He determined that the electrons travel on energy levels or orbital paths. Electrons. Sorry, I know I said they. Bad teacher, bad. Okay, and then the last one is our current model. It's very similar to the Bohr model, okay, except that the electrons can jump from one energy level to another. They're not necessarily restricted to only being in one energy level. So Erwin Schrödinger, because we love his name, he said, you know what, I think that it travels in clouds and it's swarming around. So this is the current theory that we believe. It's just a lot easier for you guys to learn the Bohr model because it is so concrete, versus this is like, this electron goes over here when it wants to, and this one goes over here when it wants to. And that's basically all you guys need to know about atomic theory, and this is what your quiz is going to be on, so make sure you study and watch the YouTube videos. I post videos every Wednesday. Just kidding. That was my shout out to Jenna Marbles.